You know, I said function notation 4.7, but it's really not. 4.7 is just like the very first part is where they introduce this function notation. There's not much else in that section. We'll get to the rest of that section later. But, you know, this is a unit on functions and relations, so we really should finish with understanding this function notation. So if you have an equation like y equals negative 3x plus 6, it's solved for y. We've already kind of said that means it's a function because it's solved for y, right? Then you could see it also written like, instead of using y, we use, this is a notation, f parentheses x, right? It's saying it's a function rule that has x as the variable in the middle of it on the right-hand side. Now, you can switch interchangeably between y and f of x, because in the end, that function rule, what is it going to give you? It's going to give you y values. So people will use those interchangeably, but you also need to, you're going to see this function notation all, you know, half the time at least. It's how we talk about things in general, because we're going to talk about lots of kind of functions, not just one. And, you know, so the things that apply to all of them, we're going to talk about by saying f of x, right? You read it like that. You read it as f of x, right? F of x equals. So you need to keep in mind, f of x and y are the same. Right? They are the same thing. You say, are they the same? Yes, they're the same thing. And then this thing right here, right, this f parentheses x, that is not a multiplication, right? You can't peel away the f from the parentheses x. They all go together, right? So don't try to divide by f. I've had that happen before, right? Can't divide by the f. It's stuck to the x. Okay. Good. Micah, still going? Okay. Benito. Okay. So you can get asked the questions. Usually this is kind of how it gets used. You could be sent, find, you know, f of x equals negative 3/2 x plus 5, right? Evaluate f of x when x equals 0, right? What it means is plug in x equals 0. I mean, it's just turning it into an evaluate an expression, which is something we did since day one, right? That's all it means. We're going to evaluate. I don't want to do that. Undo. I want to be in blue. Right? And the way we write it is f of 0 equals negative 3/2 times 0 plus 5, which is 5. Right? That's what it means to say evaluate a function. I mean, plug in whatever's in the parentheses with that goes into place of x. Evaluates a function when x equals 2. Right? F of 2 equals, what do I do with the 2? What is that going to look like? Plug it in here. What does it look like? Negative 3/2 times 2 plus 5. which is negative 3 plus 5, which is 2. So f of 2 is 2. Yeah. If it says find f of 2, that would be good just like it is. That would be good just like it is. Yeah. Done, Tate? You know, or it could just say, and notice that now I didn't even use the f, I used g, because you can use other letters. G of x equals 2x minus 3. So it's a different function rule. And this time we're going to use a g to represent it. Find g of 0. Again, how would I find g of 0? Plug in the place of x, put a 0. Minus 3, which is negative 3. Find g of 2. 2 times 2 minus 3. 1. So we have to get used to this function notation and know what it means to say evaluate it or find f of something. I mean, it gets, you don't even see like where this is going, but ultimately we'll plug in kind of not even numbers for the x. Sometimes we'll plug in other algebraic expressions for x. Those are called compositions of functions. But it starts here. I mean, just what is the basics? What does it mean to say f of something or g of something? Right? It means plug in whatever is in the parentheses in the place of the variable in the expression. And in fact, I think that I know what's on the next slide. You know, like I showed on the last one, it doesn't have to be f. It could be g, right? It could be h. It could be anything. I think on this one that we did in the homework, the function was y equals 2x plus 3, right? Y equals 2x plus 3. And we found the values in our table of values for x equals negative 4, negative 2, and 0. I mean, a lot of times when you get up in math, you would just say y of, and use, it's kind of like a hybrid between saying y and the function notation. Y of negative 4 is negative 5. Right? Y of negative 2 equals negative 1. Right? So function notation, you can use any letter and any variable. I mean, this one here, we did this in the last lesson. At the end, we were talking about somebody's going to run, and we had an equation d equals 6t. So in that sense, since it was solved for d was a function of t, right? It depended on t. So you can have anything. You don't even have to have lowercase. It could be capital letters, right? It could be anything. You'll see it. You have to recognize some letter with a parentheses variable inside. It's a function notation. That's what they expect. I mean, what about? So here's an equation that we would consider to be a literal equation, right? Something that we solved before. PV equals nRT. Now, what is the operation going on between the P and the V?
P of V?
No, it's a multiplication, right? P times V. And you know you could write a multiplication with parentheses. But we would never write that like P parentheses V to mean multiplication. Because then you might think this might be function notation. Maybe P is a function of V. Yeah. Yeah. PV equals nRT. Nobody, you guys too young to be in chemistry, right?
No, we are in chemistry.
So you've had PV equals nRT?
No, I was lying. Please pardon the interruption. We're missing 13 students for the Y Street orientation. If you're supposed to be in the auditorium, please report there at this time. Thank you.
I don't remember they sent us a list of that. 8 o'clock. I mean, you will deal with, quiet please, you will deal with, in chemistry, when you get there, PV equals nRT is called the ideal gas law. It tells how, for a fixed amount of gas, the pressure, the volume, the amount, which is N, and the temperature all relate to each other. The R is a constant. It's also a very big thing in meteorology because in the end, what is the air? It's a gas. Thanks for backing me up on that. Okay. So, what is the value of f of x equals 3x minus 15 when x equals negative 3? What am I going to do with the negative 3? F of negative 3 equals 3 times negative 3 minus 15, which is negative 9 minus 15, which is negative 24. Okay, the next one is a U try for you. Evaluate h of x equals negative 7x when x equals 7. What'd you get? Oops. H of 7 equals negative 7 times 7, which is negative 49. Okay, now here's the other way you can get asked the question, right? Not that they're going to tell you the x value to plug in, but instead they're going to tell you what the f of x equals, right? You're not going to substitute for x, you're going to substitute for f of x, right? So it says, for the function, f of x is 2x minus 10. Find x so that f of x equals 6. So what they're telling you, substitute in place of the f of x, put a 6. So now it's 6 equals 2x minus 10. So if they give you the f of x, then you need to replace the f of x with whatever it equals. Now that's an equation we should know how to solve, right? Solve for x. It says find the value of x. Add 10. 16 equals 2x. Divide by 2. X equals 8. Okay, Sarah? Drew? Black is still going. All right? Okay, so here's their problem for this next thing. The gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x equals 3x or 37x plus 7, where x is the number of years since 1995. Okay, graph the function and identify its domain and range. So they've already got the, we're not doing the work, it's already there for us, but just to show. So they made a table of values. Now it's not x and y, it's x and f of x, which we know to be equivalent, because y is equivalent to f of x. They substituted x equals 0, 1, and 2. Where'd they get that from? What's that? They made them up, right? I mean, is it going to make sense to have negative x's? They said to make it the years since 1995. So, okay, they start with 0, which means what year is it? 1995. Okay, and then they put in a 1, which means it was, and 2, 1997. Now, why didn't they keep going? Maybe they, honestly, you know why they didn't keep going? Actually, they could have just stopped at 2, right? Because this is a straight line, you only need 2 points. And this is coming from section 4.7, which is like after we've already established the fact that you don't need 5 points to determine a line. But they did do 3. So they did 1 extra that they didn't really need to do. Because, when I'm looking at it, I'm going, well, since 1995, that was 20 years ago. I mean, are you sure we didn't want to plot some more closer to our time now? But they're clearly taking advantage of what they know about a straight line. You don't need many points to determine what it's going to do. So they plugged in 0, 1, and 2 for x. In that expression, they found their f of x, 7, 44, and 81, and they plotted 3 points. These 3. And then they connect them with a line, right? Because that population isn't just at those one whole year after, right? They're growing in the middle too. So that's an infinite number of points on that line. Now, how would we describe the domain of this function? X is, it's only going to the right of here. So how do you describe that? Greater than or equal to 0, right? That's the domain. The range starts here. What was that lowest value? When we plugged in 0, it was 7. So if that's 7, how do we describe the y values on that line? Y is greater than or equal to 7. Up from there. So you try. Use that model from the example 3. Define the value of x so that f of x equals 155. So I'll rewrite it here. F of x equals 37x plus, is that a 7? Yes, 7 plus 7. So they're saying if f of x equals 155, find x. Anybody got an x?
I've got -4. Oh.
-4?
Dang it, I'm so sorry. I'm not. Wait. You know why? Because I'm retarded. And I put...
Remember, when they tell you the f of x, you substitute f of x for that with that number. No more f of x. And then it becomes an equation to solve fairly easily, right? Subtract 7. Divide by 37. X equals 4. So what does that mean? What does it mean to say that means f of 4 equals 155, right? But again, what was this function representing? Number of wolves as a function of years since 1995. So what does it tell you that f of 4 equals 155? So go ahead, Victoria. Yeah, that in 4 years after, which is 1999, the population is 155. I mean, that's kind of turning it from the abstract math problem back into, okay, this is the thing we were discussing in the first place. F of 4 equals 155. I think I got one or two more. Okay, so here's a function. F of x equals negative x plus 4. Okay, and I'm going to graph the function by plotting the points. X equals 0, 1, 2, 3, and 4. So let me plug in one at a time, make my table of values using that. What is f of 0? Right, plug in 0, what do you got? 4. What is f of 1? Negative 1 plus 4, 3. What is f of 2? F of 2, 2. F of 3. And f of 4, 0. So if I plot these points, right, I'm going to get 0, 4, 1, 3, 2, 2, 3, 1, and 0, 4, 0. And then this is a line. So what is f of 0 on that graph? That point where the graph crosses the y-axis, that's called the y-intercept, right? And it's always the case, if you have a function, if you find f of 0, that's the y-intercept, okay? And then what is the value of x when f of x equals 0? Look in your table of values. When f of x is 0, x is 4. So what point is that on the graph? It's the x-intercept, right? What's that? It's the intercept. It's called an intercept, right? So in this case, it's called the x-intercept, right? That point right there, where this line crosses the x-axis, that is called an x-intercept. But it's got another name. And when we go in the 2 slides, we go back over the objectives that we're supposed to be getting out of this. You call the value of x that makes f of x equals 0 is called a 0. This is a 0. It's the value of x that you plug in so that f of x equals 0. Oh, that was wrong. Can't use the word. I got to use the 0. So we're expected to know what that word means. right? It's the x-intercept. It's the value you plug in for x to make f of x equals 0. So if it says find the zeros, that means you substitute f of x equals 0, solve the equation. Remember, on the x-axis, y equals 0. You're not above, you're not below, you're right in the middle. On the y-axis, x equals 0, right? You're not to the left, you're not to the right, you're right in the middle. Right? That's why you find the y-intercept by plugging in x equals 0. That's why you set f of x, or y equals 0, to find the x-intercept. So, find the mistake.
Oh, I know what they did.
You do.
Oh, look, they put -3. They're divided that way. They divided. They divided by the -3. Because you're not supposed to separate them.
Oh, really? Drew, what did you say? Okay, no, that's not it. Who else sees it? Who sees it? At who else?
No wrong thing. There's nothing wrong.
Okay, so they're finding g of -3, right? Here's our function g. What does it mean to say find g of -3? You plug in -3 here, which they did, and then you calculate it, right? There's no -3 times g. That's function notation to say g of -3. It's not -3 times g, right? Yeah, that's the mistake. It's the thing I've warned you about. Don't look at it like this is a multiplication. It's not. It's function notation. It's g of -3. So don't turn it into that. They should have just said this is 15 plus 3, 18, done. That was the answer. Okay. So let's see. How many pages of homework tonight? So here's we've done most of the stuff here. Okay, we've done most of this here. But here's the one. Second bullet there. Identify domain, range, and zeros. That's what they mean by zeros. It's x-intercepts. It's the value of x that makes f of x equals 0. There's your homework.